So from the previous video, we were using the formula, this formula, derivative of x is equal to h, which is 0, x plus h minus x over h. So we're using this formula to find these values that are here. 1 over 2. So I can just remind you again of what we did. And the f x plus h, this was equal to h plus h minus x over h. This was 0 and h into h was 1. So you can see that this is what we found. But we saw this to be quite long. So there's this other, these rules of differentiation that I can say are shortcuts of finding the derivative. So rules of differentiation. So for example, this one we found x was equal to 1 using the derivative method, or using the first principle. We use the first principle for this. First principle to find this principle. So the rules of differentiation I can say are kind of like shortcuts to this. They're kind of shorter, and I just want to prove that you can get the exact same answer using these other rules of differentiation. So the first one is, let's say we've got x to the power n. So if we're given x to the power n, then our derivative, which is our derivative of x, is going to be equal to n x n minus 1, which means the power subtracted by 1 and multiply the x by the power. So let's see if we find this sum, x is equal to 1 here. So fx is equal to x. So we need to find the derivative. So our derivative is going to be equal to our power. The power here we have is 1. So we've got 1 times x, 1 minus 1, which is equal to any x to the power 0, and any number to the power 0 is 1. So you can see we've gotten the same as what we used to get the first principle. We can try the second one, which is 1 over x. 1 over x is the same as x to the power negative 1, which is equal to multiply the power times the constant, so negative 1 times x, and negative to the power negative 1 minus 1. This is going to be negative x to the power negative 2, and this is going to be equal to 1 over negative x to the power 2. You can see which is what we got here. What we got here. Then we try x to the power 2, which is equal to, so we multiply the coefficient by the power, to be 2 times x, and then subtract the coefficient by 1. We're going to have 2x, this is 1, the power 1, which is just 2x, which is what we found here. Then x to the power 3 is equal to 3x 3 times x, and 2 and 3, sorry, 3 minus 1, 3 minus 1 will be left with 3x to the power 2, which is exactly what we found here. And for the root, one with the root, this is the same as x, the same as x to the power 1 over 2. We're going to have 1 over 2 times x, and 1 over 2 minus 1. It's going to give us is 1, going to have 2, 2 is 1 minus 2, which is negative 1 over 2. So we're going to have x over 2 minus 1 over 2, like this. And to get rid of the negative, it's going to be 1 over 2 x 1 over 2, and which is equal to 1 over 2 root of x, which is exactly what we found here. So you can see that this is way shorter than using the first principle method, but there'll be some questions where you'll be required to use the first principle method.